Bismillahirrahmanirrahim. My name is Mudassar Hussain, roll number 17033, and my presentation topic is green chemistry and its principles. First of all, definition of green chemistry. Green chemistry is the design of chemical products and processes that reduce or eliminate the generation of hazardous substances. It is the idea of making chemistry more environmental friendly. History of green chemistry. 6 points on the history of green chemistry. First one is in early 1900s, chemistry grew up from the theories done in the labs to an industry done in the factories. People create electricity in power plants, make fuel for the car in different industries. In mid 1900s, the negative effects of the chemical pollution were becoming apparent, and in many countries, people around the world began forming groups with their government to combat with the pollution. And then America formed the Environmental Protection Agency (EPA) in 1970. In 1990, the Pollution Prevention Act was passed. However, green chemistry is always attempting to take further steps in its goals. There are 12 principles of green chemistry. First principle is prevent waste. Design reactions that leave as less waste as possible. Number two is maximize atom economy. Two reactions are given. First one is stoichiometric and second one is catalytic. Atomic efficiency of first one is 42%, while atom efficiency of second one is 87%. So we should choose that reaction whose atom efficiency is more. So here we will choose catalytic, not stoichiometric. Number three, design less hazardous chemical synthesis. Design reactions that use and produce as few harmful chemicals as possible. Number four is design safer chemicals and products. Design chemicals that can perform the same action as those that exist but with less toxicity. Example is paint, which is less toxic, easy to use, and do not create harmful effect. Number five is use safer chemicals and products. Avoid using toxic chemicals whenever possible. Example is Q Division Inc. developed a less hazardous method for creating screens. Number six is increasing energy efficiency. Create reactions that can be done at room temperature and standard pressure whenever possible. Example is 2005 winner of the Nobel Prize in Chemistry. Number seven is use renewable feedstock. Feedstock starting material used for the many reactions. Use starting materials from renewable resources rather than limited ones like fossil fuels. Renewable resources like water, sunlight, these are not going to be run out for the rest of life, so we should try to choose those substances which are renewable, not those which are unrenewable. Example of unrenewable resource is petroleum, and renewable example is glucose. Avoid chemical derivatives. Avoid using blocking groups or protecting groups whenever possible, as it generates additional waste. Example is tert, butyl, carbonyl. Protecting group BOC in short कहा जाता है, which is used as protecting group on amino acids. Number 9 is use catalyst, not stoichiometric reagent, as I discussed earlier. In principle, catalysts are not consumed, meaning that can be regenerated and reused within the reaction. Example is catalytic aerobic oxidation is much faster than the aerobic oxidation without catalyst. Number 10 is design chemicals and products that degrade after use. Develop products that will naturally degrade in the environment rather than remain and cause more pollution and cause troubles not only for human but other creatures as well. Number 11 is analyze in real time to prevent pollution. Monitor all reactions to ensure they are creating as few unwanted byproducts as possible. Example is real time IR monitoring. And the last one is minimize potential for the accidents. Design chemicals and reaction in such a way that they have smallest possible risk for the accident. So you should practice lab safety to prevent spills or other harmful accidents. Thank you so much. Allah Hafiz.